In today's video, we are going to talk about how to sketch trig curves, sine curves, and tangent curves. Okay, so we would do all the three: sine, cosine, and tangent. So if you haven't subscribed already, now is the time to do so to enjoy this video and many more to come. So let's start with this particular question. This question came, I think, in 2021. Yes, May, June. It says that first we are supposed to study this function and then talk about its amplitude and period. Well, this is a cosine curve, all right? So the parent function should have been, let's say, a cos bx plus c, where a is what we call the amplitude. Okay, A is the amplitude, b talks about the period, and then C talks about the vertical translation. Okay, you can call it a vertical shift, right? Let's call it a vertical shift because it moves the curve up and down. All right. Okay, so now that we know this, we can study this, and we know that this is only one value here. Okay, so we can say that the amplitude is 1. And then the period is always, for the cosine, the period is 2 pi, right? But this is in degrees. Therefore, we can say that it is 360, right? But it's 360 divided by the coefficient of the x term. And this is 2 over 3. So divide by 2 over 3. And if you put this thing on the calculator, you should get 540. All right, so we know that the period is 540. Now, the period basically means that in how many degrees would the curve, would you sketch the full curve? Now, cosine curve looks like this. All right, so we are being told that from 0 all the way to 540, you would have finished sketching the cosine curve. So that's basically what the period is telling us. Okay, now, so I think we can just get a rough sketch of it. It looks like this. All right, so, and we know that it ends at 540. All right, but they want us to sketch all the way to 810. So how do we do that, really? Okay, so what you want to do is to remember that they have pushed it down by what? 2 units. That's a negative 2. So you can rewrite the curve as 2 cos 2x over 3 minus 2. All right, so they have pushed it down. You don't worry, start by sketching this part where they have not pushed anything down. Right, it will help. So you have something like this, and then if the period is 540, the next thing I would like you to do is to divide it into 4 quadrants. So 540 divided by 4 will give us, let me check, 540 divided by 4, that's 135. Okay, so that means that you can get it into 4 quadrants, 135. Let's see, so 135 plus another 135 will be 270. This is the next quadrant. Then plus another 135. The third quadrant is 405. So that's here. So we've divided it into 4 quadrants beautifully. This is the first quadrant. All right, so let's start from here. Then cosine will come, it starts from 1. All right, so this 2, 3, 4, 5. And then this neg 1, neg 2, neg 3, neg 4. Cosine is from 1 to negative 1. Right, so it comes to negative 1, it goes back to the origin, and then it ends here. All right, however, we are told that we should sketch it all the way to 810. That means that we continue. So let's say it continues from 1. It will have to go to the center. All right, so that is basically, you can check 540 plus 135 again. That takes you to 675, which is the middle of 630 and 720, and then plus 135 is giving us 810, which ends here. All right, so you have something like this. However, remember that they have pushed it down by 2 units. So bring every single point down by 2 units. So this goes down 1, 2 is here. This also goes down 1, 2, which will be here. This goes down 1, 2 will be here. This will also go down 2 units. This will go down 2 units here. This comes 2 units, and then 2 units as well. So your curve really looks something like this. All right, so this is how your curve looks like. Now remember that what you have here, the -2, all right, that's the new principal axis, so indicate on it like this, and then you are done sketching the curve. All right, so since we don't need the initial point that we plotted, you can just clean it, and then it will look clean like this. All right, and you are done. So that's how we sketch the cosine curve. All right, so the next thing is that we want to sketch the tan curve. We have y is equal to a plus 2 tan bx. They are telling us that the period is 480. Now remember that even though cosine's period, okay, for cosine, period is 2 pi or 360 over b, for tangent, period is 180. Therefore, what you have is 180 over the coefficient of the x term, which is b, is equal to 480. So b is basically 180 divided by 480, and 180 divided by 480 is going to give us 3/8. Okay, so that's the value of b. Now they said we should find a2. That's why they said it passes through this point. So our y has now changed to a plus 2 tan 3/8x. Okay, now y is -4, x is 0. So we have this tan, basically this is 0, right? Because if you multiply 3/8 by 0, you get 0. Now if you check tan 0 is really let me look at it. It's in degrees, so let me change my calculator to degrees. Tan 0 is 0, so that means that a is -4. All right, so you are done finding your a and b. So that means that your curve is now y is equal to 2 tan 3/8x minus 4. This means that when you finish sketching this guy, push your curve down by 4 units. All right, now the parent function, we need to learn something here before we sketch it. The parent function tan x, right, has a vertical asymptote pi on 2 and then negative pi on 2, which basically means -90 to 90. This is where the asymptote will be. Therefore, to find a new asymptote for this transformed function, we need to equate the angle here, all right, the 3x/8 to -90, and then we will also equate the 3x/8 to +90, because these are the asymptotes of the parent function. So you have 3x is equal to -720, and then you have x is equal to, let me see, 8 times 90 divided by 3, that is 240. So this is -240, and basically this will give you 240. That should tell you that what you are about to draw, the asymptote is happening at 240 and -240. Then based on that, you can get the other asymptotes. Remember, they told us the period is 480, which is here. So you can divide the period into 4, all right? So 480 divided by 4 will give us 120. So this will be half of it, which is 240. Then this is 120. Then this one will be 240 plus 120, that's 360. All right, so we have divided it beautifully into 4 quadrants. We know that remember, they want us to draw it from 0 to, let me underline that, from 0 all the way to 480. So we don't care about the negative asymptote. We are just going to work with the positive one. At this point, I will clean this workout. All right, or I can just squeeze it, and then we will put it somewhere here so you can still look at it. All right, so what we do is that we get our asymptote on 240, which is this. Every tan curve you draw should have an asymptote, okay? All right. Now, after 240, remember that it's coming from negative 240 all the way to 240. These are the two asymptotes. All right. So that means that basically you have the distance between these two asymptotes is 480. So if this is 480, the next one that will come would have been 480. All right. It always increases by your 240, right? From here all the way to here is the same distance that will happen from here all the way to there, which would have been 720. Okay, so this actually denotes half of the curve. All right, this is the argument I'm making. If this is your negative 240, then your tan curve would have looked like this, right? So from 0 all the way to 240 really is half of the curve, and then this one would have looked like this. All right, but since we don't care about the 720 part, we would clean all of this. It's not part of the curve. All right, so you have something like this, and then you have something. This is also not needed because we don't need the 0 part, so that part should also go away. Okay, so the next question is that they pushed it down how many units? -4, right? So that means that I'm going to push our curve down to -4. So let's say this is -4. All right, so I'll push the curve down. That means I'm going to have something like this. So we can delete or clean the initial one. All right, so we have something like this. And then this one too, we have to push it down by -4 units, so which is somewhere here. All right, so our curve will go down like that. So that means that we can clean this. We don't need it. So this is how they expect you to sketch this tan curve. All right. Okay, let's continue. The next thing is they have drawn a cosine curve for you, and they're asking you to identify A, B, and C. Well, we have to really read what is happening, and then based on the details, we can find what A, B, and C are. So we are told that the curve meets the y-axis at this point, at the x-axis at that point, the minimum is Q, and then the period is pi radians. Of course, you know that the period of a cosine curve is 2 pi, but this one, the question is telling you that the period is pi, so pi is what you use. Remember that period is 2 pi over b, all right? But they are saying that this period is pi, so just equate it to pi. That means that b is equal to 2 pi over pi, giving us 2, okay? So now we found the value of b to be 2. The next thing that you want to do is to use these arguments that they have given you, this guy and then that guy. Let's first go to the y-axis. So your curve is now y is equal to a plus cos 2x plus c, right? So if on the y-axis x is 0, so you have something like this. Cos 0 is, I think, let me check. Cos 0 is, this is in what? Radians, right? Okay, but cos 0 is 1. Actually, it's not plus. I think I made a slight mistake here. It's cos 2x, all right? So that's it. So cos 0 is 1. So that means that we have 3 is equal to a plus c. So let's call this equation 1. And then look at the second case where you have this point, the point R. They said y is 0, x is 5 pi on 6. So you have a cos 2 into bracket 5 pi on 6 plus c. Right. Now we can make sure that your calculator is in radians, and then 2 times 5 pi on 6 is actually 10 pi on 6. So cos 10 pi on 6, calculator tells us that the answer is half. So you have half a plus c is equal to 0, which is the same as 0 is equal to a plus 2c. Okay, let's call this equation 2. So you can solve this simultaneously. All right, I can decide to subtract the two equations, equation 2 minus equation 1. That will give me c is equal to 3, actually negative 3. And that also means that I can put that into one of the equations. That will mean a is definitely equal to 6. Okay, so if you solve it simultaneously, that's what we are going to get. Therefore, we have a equals 6, c equals negative 3. All right. Then they want us to write the coordinates of p. Let's go back and look at p. Well, p is here. P is some x value, right? And the y value is 0 because it's on the x-axis. So don't worry. Grab your curve, which is y is equal to 6 cos 2x, all right, minus 3. If y is 0, then you are going to get 6 cos 2x minus 3, which is the same as 3 is equal to 6 cos 2x, right? Now, I guess we have to clean this part. So this basically means we have 1 is equal to 2 cos 2x, which is half equals cos 2x. Okay, so you can take the cos inverse of that. That will give you 2x is equals cos inverse of 0.5. And let's see, cos inverse of 0.5 is actually pi on 3. So x is pi on 6. Okay, so we found the x value. I told you the y value is 0, x value is what we are looking for. So we can say that our answer is pi on 6, 0. Now let's go and find the coordinates of Q. Well, Q happens to be the minimum point. And remember that the cosine curve is symmetrical. All right, so that's the point of the line of symmetry will pass through Q. They told us that the period, that is the degree by which our curve would take a complete shape, is pi. That means that, remember, the line of symmetry divides a curve into two equal parts. So the x component there is pi on 2. We are left with a y component that we don't know. But you don't have to struggle. Just take your curve, y is equal to 6 cos 2x minus 3. Put the x value there, which is pi on 2. So that will actually give you 2 pi on 2, which is pi minus 3. Now, cos pi gives us negative 1. So we are looking at negative 6 minus 3, giving us negative 9. So your point is pi on 2, negative 9. That is the Q they are looking for. Now we have a sine curve that they want us to deal with. Okay, so basically they are looking for A, B, and C. Okay, now the first thing I would like you to do is look at where the sine curve is beginning and ending. Now, if you look at that, you can just draw a line through it. It will help you to get a new principal axis. Okay, all right, so if you look at it, the curve has been pushed up how many units? 4 units from its origin. So that means that C is 4. Okay, that way you've been able to find C without much complication. Now you want to find A, no problem. A is basically the maximum point minus the minimum point divided by 2. So A will be 7, all right, minus 1 divided by 2, and that is 6 by 2, giving us 3. So A is 3. Then we are left with B, this particular B, and that is a measure of period. Remember, what is the period? Well, the sine curve is taking a complete shape from negative pi on 2 all the way to pi on 2. So if we are moving from here to there, you are moving about 4 pi. Look at it, 1 pi, 2 pi, 3 pi, 4 pi. So period is basically 4 pi. So you have 4 pi is equal to 2 pi over B. Remember, the sine and cosine curve takes their complete revolution within 2 pi, all right? So that means that you have B is equal to 2 pi over 4 pi, giving us half, all right? So you are done. A is 3, B is half, C is 4. So within about maximum of 2 minutes, you've been able to solve to get your 3 beautiful marks. All right, now let's take a look at another tan curve. First, they want us to solve this thing and then give our answer in terms of pi. Now, I have already done trig equations on this channel. You can check it out. And I mean, I solved a lot of examples on this. Anyways, let's solve this particular one. Remember that this is x and this is 3x. So we have to transform this guy. Multiply through by 3, this thing. So that means that we are dealing with negative 3 pi on 2. And then we have 3x. Then we have 3 pi on 2. This way, we are ready to start solving. So 3x is equal to tan inverse of negative 1. Make sure your calculator is in radians since you are dealing with pi. All right, so tan inverse of negative 1 is basically negative pi on 4, sorry. But how do we get the other angles? Well, you can use what we call this cast method, where this is cos, this is all angles, this is sine, this is tan, right? The first one means that only cos is positive, all the trig ratios are positive, only sine is positive here, and then only tan is positive there. Okay, now when we took our inverse, our first angle is a negative angle. That means that the angle is down here. This is pi on 4. But don't worry, let's demarcate the whole thing. This is pi on 2. This is pi. This is 3 pi on 2. Let's end at 3 pi on 2. We are looking at the positive part, only this part, okay? All right, so that means that you can use the vertically opposite argument and then extend this line. Remember that they said tan is negative, so it's supposed to be in this quadrant here and then in the quadrant there. So this is pi on 4 as well, because the angle here is vertically opposite to the angle there, so they are equal. All right, so if we start from the origin, we meet this curve here, and then we also meet this curve right. Oh, in fact, we can't go beyond pi on 2, so that wouldn't necessarily work. So we meet only this one. So how do you get that? You can just do pi minus that. So you have pi minus pi on 4. I think that should be 3 pi on 4. But anyways, let me check it out. Yeah, that's true. 3 pi on 4. All right, so let's check the other side. So this will be, if we are going here, the angle is a negative angle. So you have negative pi on 2, negative pi, and then negative 3 pi on 2. So if we are going this side, you are going to meet a curve here. That's the first one. I've recorded it. And then the next one, you meet it right here. So that's negative pi minus pi on 4. All right. So you have negative pi minus pi on 4. And that's negative 5 pi on 4. Remember, this is 3x. So x itself is you dividing everything by 3. That will be negative pi on 4. You will get 3 pi over 12. That's basically pi on 4. I mean, we can simplify that and write pi on 4. Pi on 4. And then this is going to be negative 5 pi on 12. Okay, so we are done. Now they want us, that's why it's actually 4 marks. If you do only one angle, then I believe you'll be getting maybe 1 or 2 marks out of the 4. All right, now they want us to use part A to sketch this curve. Well, just be interested in this one, all right, and then later on you can push it up by 4 units, or you can also start by drawing from the principal axis, which is 4. All right, so no matter how you do it, I mean, you have a choice. Okay, now let's sketch it. Remember that the principal axis of a tan curve is having asymptote from negative pi on 2 all the way to pi on 2. So what you want to do is to equate a 3x actually to negative pi on 2, and then you also equate 3x to pi on 2 to look for the new asymptotes. All right, and that will be negative pi on 6 against pi on 6. So these are going to be your asymptotic lines, the vertical asymptotes. But how do we identify them? All right, don't worry. They told us that, did they give us the period? No, they did not. But we know that the period of the tangent curve is what? Is pi. Okay, so we can always divide it into, let's see, the period is pi, and then we would divide that by the coefficient of the x term, which happens to be 3 in this case. Okay, so that means the period is pi on 3, right? So if we have pi on 3, we can divide that into 4 quadrants, so that we know what one quadrant's value is, which is pi on 12. Okay, now why do I need a pi on 12? Well, it helps me to understand the demarcations that they have done. Each demarcation, that value should be pi on 12. Now let's see if it tallies with what they have done. So if this is pi on 12, the next one will be 2 pi on 12, which the next one will give us 3 pi on 12, and 3 pi on 12 is pi on 4. So it means we are right. Okay, we are correct. All right, and also 2 pi on 12 is the same as pi on 6, and that is the asymptote. So it helps us to find all the asymptotes. So this second demarcation is the asymptotic line. So I can impose the asymptote on it beautifully like that. So we can delete everything here. We don't need it. All right. So the second one is also asymptotes. Okay, there are more asymptotes to find, but before you do that, check how many distance, all right, of value is in between the asymptotes. That's 1, 2, 3, 4 demarcations. So the next asymptote you meet from here will be 1, 2, 3, 4, which is on this one. So you can draw your asymptotic line like that, and then we can clean this. You don't need it. It just helped you to check things out. Okay, then the next one from here will be 1, 2, 3, 4. So it's also going to be on that line. All right, then you clean it. You don't need these things. All right, now if we are going to sketch, then it is going to look like this. All right, tan looks like that. Okay, so you have something like this, and then you have something like that. However, if you look at it, they want us to push our curve up by 4 units. All right, so if this is your axis, the 4 axis, you can just call it 4. So the new curve is going to be pushed up 4 units. I'm going to draw that one in black, and then later on erase the ones that we do not like. All right, and then this one is also going to look like this, and then this one is also going to look like this. All right, so we are just pushing everything up by 4 units. Then we clean the one that we do not need. I guess I'll have to resketch it, but you get the idea. Yeah. All right, so let me quickly beautify our curves. Okay, so this is basically what they are asking you to draw. Okay, all right, now let's look at the next question. They want us to write down the period of this argument. Well, cos has a period of I was about to write 2 pi, but look at this, it's in degrees, so you just write 360. Okay, 2 pi is same as 360 divided by 1/3, which is same as 360 times 3, right? That's 1080. All right, that should be 1080. Okay, so that's for just for 1 mark, because finding period is nothing difficult, so they wouldn't give you more marks. But this is where you score, because they want you to sketch this particular curve. Okay, like we always do, if you know the period, which is 1080, just divide it by 4 so that you know the value of one demarcation. So 1080 divided by 4 is giving us 270. Okay, so this is actually 270. If you want to know if that is 270, you can just do 180 plus 360. 180 plus 360 divided by 2, that gives you 270. Easy. So that means that this is also negative 270. All right, so that is the, a cosine curve looks like, a cos curve looks like this, right? Good. Now, there are 4 things that happens, actually more than 4, but this is the first point. Then it goes to the origin, goes to the turning point, comes back to the origin, and then so these are the points that we use. Now the first point is the one on the y-axis. The second point is the first point on the x-axis, right? And that is the 270. That's the demarcation for one value. So you know that it's going to be on the y-axis at this point, the x-axis here, the x-axis there. And then they said that this is 2, all right? The amplitude is 2, so you start from 2 instead of 1. Okay, so if I'm to loosely sketch this, remember that it has to go, after here, has to go to our turning point to 10, right? But the turning point would have happened if we were to add, we said each is 270, so 270 times 2, that's 540, would have happened at 540, probably here. So it would have turned around this point, but it's not part of the curve, so it wouldn't turn. This would look like this. All right, something like this, and then this will also come down like this. Okay, but however, they want us to push it down 1 unit, so that means this will come down here, this point comes here, this particular point will also come down here, and then our curve will now look like this. Okay, so once we've drawn the curve, you don't need all these ones. You have to let them go. Okay, so you've sketched it beautifully like that. All right, so let's consider our last question. I mean, you can find a worksheet there and solve the rest of the question if you really understand what I'm doing. So the last question says that y is equal to a sine bx plus c, right? Now it has a period of 180, but you also know that the period for sine is 360 over b. Okay, so is equal to 180, just equate it to 180. So b is equal to 360 over 180, giving you 2. So b is 2. All right, so if b is 2, let's find the rest. It says that the amplitude is 20. That means that a is 20. But it passes through this point. So but at this stage, you have 20 sine 2x plus c. So you can use this point to help you out. Y is negative 3. You have 20 sine 2x. But the x here is 90, so that's sine 180 plus c. Now change the calculator to degrees and then check sine 180. Sine 180 is 0. That means that c is negative 3. Okay, so that means you found your c, you found your a, you found your b of 2. All right, so that means that the curve is, you are done. The b part has nothing to do with the a part because the b part is a tan curve. Okay, they want us to sketch this tan curve. No problem. All that you need to do is to look at the degrees. They are using the accuracy here is in degrees, and tan has asymptotes at negative 90 and 90. Therefore, just equate the half x to 90 and then equate the half x to negative 90. All right, so that means that x is equal to negative 180 and then x is equal to 180. These are your new asymptotic lines. Now, unfortunately, 180 would have probably been here, right? 180, and then negative 180 would have probably been here, right? If we were to extend this, and they would have been the asymptotic lines. I want to clear this part. All right, they would have been the asymptotic lines. But like I was saying, unfortunately, it's not even part of the curve. So that means that the curve we're about to draw has no asymptote. Okay, now the next thing that you want to check out, basically, you know what, you just sketch the curve. It would have looked like this, all right, without the -4. Okay, the -4 tells us that we should push the curve down by 4 units. It would have looked like this. So if we push it down by 4 units, that would mean that now your principal axis, let's use maybe blue line. Oh, this, okay, let me use this and then go and write a -4 there. So your principal axis is the -4 here. So we are going to push this curve that we've drawn down by 4 units. Okay, so that means that you are going to have a nice curve like this. Oh. All right, it would definitely touch the 135 line and the -135 line because the asymptotes themselves are around 180 and -180, right? So basically you're having something like this, so you don't need these things here. Make sure you don't leave it in the exam, all right? It's not part. So once you indicate those 180 things, it means that you didn't obey instruction, because the question says that sketch it between -135 all the way to 135, right? So it should look something like this for your tan curve, and then you are done. You may be wondering that the 3 there, well, the 3 there is going to stretch it, all right, but that stretch wouldn't necessarily be seen in your drawing. Okay, so the next one is a cosine curve that I believe you can sketch. We have sine curve that you can also sketch easily, like the way we've been sketching these things, and then you will be fine, all right? So give it a try. I left the years beneath there, all right? So you can always check the marking scheme to see if you are doing the right thing. Okay, so until we meet again, take care of yourself. Bye for now.